This lecture discusses Chapter 13, Freshwater, Streams, Lakes, and Groundwater. First, we will discuss an introduction to streams. Then we'll discuss stream geomorphology, or changes in the landscape as a result of stream flow. And finally, we will discuss groundwater and aquifer resources. Freshwater is defined as containing less than 500 parts per million dissolved salts, and it makes up only about 2.5% of Earth's water. Most freshwater is found either frozen or underground. The graphic below the text indicates the relative percentages of freshwater in different partitions. So we've got oceans consisting of most water on Earth. Then of the freshwater, most of the freshwater is caught up in glaciers and ice caps. Of that not in glaciers and ice caps, much of the freshwater is also preserved in snow and permafrost, some in lakes, very little in rivers, swamps, and as biological water in humans and other species. First, let's discuss how streams form. Runoff is water that flows downslope due to gravity. Sheet wash is the water spread across the surface. You may see this sheet wash occur during rainstorm events, over pavement which cannot be penetrated, it's also known as impermeable, or in nature where no human activity has modified the landscape. Downcutting is the deepening of a channel through erosion of water. So over time, stream channels form by eroding rocks and sediments in certain areas that are preferential for water flow. Stream channels have different features, with excess water, surface water, known as runoff, coming from rain, melting ice or snow, or from springs. On flat ground, water accumulates in puddles and swamps, but when there are topographic changes, then some of that water spills off and flows downstream due to gravity. So upstream are the headwaters of a stream closest to the areas of high topography, and downstream means closest to the lower elevations or closer to sea level. Now, different channels or tributaries contribute water to the main stream. This diagram also shows groundwater contributions to streams, which we'll talk about later. Tributaries draining into a trunk stream provide a conduit for the removal of runoff through a region. We can define drainage basins as the overall region drained by any given drainage network, and then drainage divides as the boundary between drainage basins. There are several types of drainage networks that arise in different geological settings. For example, there are dendritic, which are tree-like patterns for water to flow downslope, trellis, which form in valley and ridges where the flow is perpendicular to one another. Radial streams or drainage networks form from radiation of a central high point like a volcano or isolated mountain. Parallel streams trend parallel between ridges, and rectangular streams follow pre-existing cracks or joints, often in arid, flat areas. Here is a figure of a drainage divide, which is a ridge that separates two drainage basins. As you can see, stream A and stream B have water flowing into them from different areas, divided by the drainage divide. The major drainage basins of North America are located in this figure. They include the Mississippi River Basin, the Atlantic Ocean Basin, one that drains into Hudson Bay in the Arctic Ocean, and the Pacific Ocean. The Great Basin is a region of interior drainage with no outlet to the sea. Stream discharge is the flow of water that passes a cross-section of the stream. The greater the velocity of the water, the greater the discharge. Stream velocity also varies within a stream and is slower near the banks and in the stream bed compared to faster flow in its center. Turbulence refers to when water cannot flow in a straight path but swirls around obstacles or is slowed at margins of the stream bank. So here we've got turbulence occurring as a result of boulders on the bed of the stream and possible changes in the edge of the stream bed. This forms things like eddies and whirlpools. Permanent streams are streams that flow year-round. Many Florida streams are permanent streams. The bed of a permanent stream in a temperate climate lies below the water table, where the water table is actively contributing water to the flow of the stream. The water table is just the height of groundwater beneath the surface. Ephemeral streams exist more often in arid environments, and they only flow for part of the year or as a result of individual rainstorm events. The channels of ephemeral streams lie above the water table, where water from groundwater does not contribute to the stream. Streams erode rock and sediment material in a variety of ways, known as scouring, breaking and lifting, dissolution, and abrasion. Scouring is where water carries away loose particles. Breaking and lifting is where water separates and lifts chunks of rock. Dissolution is when water dissolves material, and abrasion is when sediment in water abrades or wears away rock like actions of a sandpaper. Some pictures of erosion from streams through scouring and abrasion are below. So how do streams transport sediment? Well, they transport sediment as a number of categories, either in the dissolved load, which are dissolved ions in the solution of water, in the suspended load, which are tiny grains that swirl along in the river or stream without settling to the bottom, or as bed load, which are the larger class that slide or roll along the stream bed as a result of water flow. Some important technical terms include capacity, which is the total amount of sediment that was transported by a stream or river, and competence, which is the maximum particle size transported. After erosion and transport, streams must deposit sediment eventually. So these deposits occur as alluvium in streams, as bars, which are coarser alluvium deposited along stream beds, or in floodplains, which are broad, flat areas adjacent to the streams. If sediment is carried to the end of streams in deltas, it will be carried out into the ocean.